This is JNGL, and I am Jacob Nash, and here we go with Unit 3, Lesson 2, and we are looking at standards 3.3 to 3.4. So on this unit, there's not just 4 standards. I think there is 7. So I decided to combine them because some of them are kind of short. So this is about the triangle inequality. Okay, that's really weird. I don't know why that O is a theta. Okay, theorem and Pythag, which I'm just going to shorten that, but it's really Pythagorean Theorem. So, okay. So, there is less slides on this one, as you can see, but I kind of crammed more on one slide, that's why. Okay, so the triangle inequality theorem. Here's some rules that we need to know. The longest side is opposite to the largest angle. The middle side is, really just the middle, like the one that's not as, in between the shortest and longest, is opposite to the middle angle. And then the shortest side is opposite to the smallest angle. So, using that, which angle is smallest, largest, in the middle? Okay, so the 3 angles, C, D, and E. Alright, so the longest side is opposite to the largest angle. So the largest side is this one right here, the 11. And it is opposite to the largest angle. There you go, it's opposite to that. So C is the longest angle. Largest angle, really. And then the middle one. 8 is in the middle. It is the next largest one. And it is opposite to the next largest angle, which is going to be this D right here. And then the shortest angle, or shortest side, is this 4, and it is opposite to this E. So the answer would be the largest one is C, the middle one is D, and the smallest one is E. That's that. Alright, now the triangle inequality theorem. So back here on this one, this is another thing that you need to know for this. So here's the rule. So this is really just a practice right here. So I'm going to box it out. And this is just the fact. The fact is that now it says A, B, or C, but it could be filled in with anything that you see there. But we have to know that this is going to be called the leg. Or sorry, that is not wrong. Wait a second. I think I messed something up. Let me look to make sure. Oh, sorry. That is not what I was trying to say. I forget the whole thing. But AC right here plus AB is always going to be, if it's a triangle, it's going to be greater than CB. So think about it. If you have 2 things like that, and then we have this, that would be the CB. Well, if it was less than that, then it would be like this, and then that, and that's not a triangle, that's just a weird thing. So that's how you know that. And then also AB plus CB would be less than AC. So AB is this, and then CB, it's going to be greater than AC. So, and then the last one is AC plus CB is going to be greater than AB. So pretty much any 2 given lengths have to be greater than the next length. So, could these be a triangle? Well, the easiest way to say is just take the 2 smallest numbers, add them, and is it greater than the last number? If so, then it could be a triangle. If not, then it's not. So 3 plus 4 is 7. Is that greater than or less than 6? It is greater than. So yes, with those lengths, it could be a triangle because that's how it works. And then these ones down here, 7 plus 10 is 17. Is it greater than or less than? Well, it's actually equal. So it couldn't be because that's just not how it works. So that one would not be. If you had to find the length. Let's say you had the lengths 6, 14, and x. And you're saying, okay, what could x be to make it a triangle? Well, what you can do is you take the two lengths, you add them, and you subtract them. And that is your top and bottom number limits that the x value could be. So if you don't understand what I just said, you can subtract them. Now, when you're subtracting them, make sure you have the biggest number on the top. So if you have 14 minus 6, that is 8. And then 14 plus 6, that is 20. I don't need to write the whole thing, but that's what that is. So then the barriers of x, this is what the answer would be in this form. 8 is less than x, which is less than 20. So what that's saying is that any value of x could be from 8 to 20, and it would work. You could say, oh, x is 19, x is 7, or sorry, not 7, that wouldn't work. X is 9, x is 13, anything like that, that would work for that value. All right, here comes the Pythagorean Theorem. So, here's what this is. Here's the theorem. So you might just know, when you think of Pythagorean Theorem, you might just think a squared plus b squared equals c squared. That's the formula, but now that we actually know what theorem means, we have to know that it's going to be an if-then statement. And if a triangle is a right triangle, then a squared plus b squared must equal c squared. So that's simple to know. I mean, let's say a was 9, b was 4, find c. We could just label that as x. 9 squared is 81 plus 16. 81 plus 16. Let's see. 81 plus 16 is going to be 97. C squared equals 97. And then really what c would end up being is square root of 97. Okay. And so now we have Pythagorean triple. This is a set of non-zero whole numbers that satisfy a squared plus b squared equals c squared. Now, what I just did in this example would not be a Pythagorean triple because is this a non-zero number? Yes. But it is not a whole number because the square root of 97 does not come out evenly. I don't know what it is, but I know that it's not one of those good ones. It is something between, it's probably about 9.8 or 9.9, but that's what the measure of that would be. And then the last thing is that there's common ones that you might need to know. I mean, there's a lot of different ones that work for that. So in case you were wondering, now we are on standard 3.4 as of this slide. But 3, 4, and 5, that is the common one. So if you ever see something where you're like, oh, 3, 4, what's that? Oh, you know it's 5. That's just a common one to know. Now, if it was like 3, 4, and then what's that? It couldn't be that. We know that the biggest one would have to be the hypotenuse. But some other ones are, let's see, 5, 12, 13, 6, 8, 10. some like that. But anyways, that's some to know. But that one's just the most common one that you'll see. And then we have this last part right here, some rules to know. If a squared plus b squared equals c squared, then it's right. All that really is just the converse of the Pythagorean theorem. It's really just the Pythagorean theorem converse. I mean, it's just saying the thing backwards of what that is. So if you see anything that kind of looks like that, and it has that's a right triangle. But if c squared is greater than a squared b squared, then it's obtuse. So if it looks like that, like that right there, and if c squared is less than a squared and b squared, like this, then it's an acute triangle. And that is it. Let's see, this last slide. Hopefully it will load. It should get there soon. Well, anyways, all done. See, that person's happy. All done. Good. And I will not do a halfway review for this one. I will only do an end review for the whole unit. But if you happen to have like some sort of quiz on the ones that I just did, then hopefully you do good. So just review.